So the new question that we have today is, how is mesoporous silica made using micelles? We saw this in class, but I would like to go back on it because some of you asked questions about it. So first of all, how do you condense silica starting from tetraethoxysilane? So this is the equations that we saw in class, starting from tetraethoxysilane. In the presence of a molecule of water, water can attack silicon to produce this, a tetravalent species. With a negative charge on silicon, a positive charge on oxygen. And then you can release here ethanol from this molecule to form this OH and O-ethoxy 3 times. What happens next is that another molecule of tetraethoxysilane next to it can also react. Similar fashion as what water does. You will attack on your silicon here, forming transition as a transition species, this pentavalent OSI, O-ethoxy 3 times here, O-ethoxy 3 times, and O-ethoxy here. What will happen again is that the O-ethoxy here can remove the proton to eventually provide this species, Si, O-ethoxy 3 times, Si, O-ethoxy 3 times, and so on. The more you add water, of course, the more you build silica, which is Si, O-Si infinitely. Now, what happens when you have micelles in a solution? So you remember that we spoke about what a surfactant is. A surfactant is a molecule that has the capability of being hydrophobic in the tail, hydrophobic, and hydrophilic in its head. This part is hydrophilic. What happens if you place this molecule inside a solution of water? Well, in water, the hydrophobic tails are going to gather in the center of what we call micelles. A micelle is simply an arrangement of surfactants that arranged in this fashion to limit the contact of hydrophobic tails with the surrounding water. Now, what happens if I try to make a thin layer of silica that is mesoporous? I will use the two things that I've just shown in the 2 past slides at the same time. I use a surfactant that you have represented here, and I use the silica precursor, which is represented here as a yellow dot. What you do here in this configuration is that you dip inside the solution a glass wafer, and then you pull it out. When you pull it out, you wet here your surface with some solution, and as you take it out, you start evaporating your solvent. In this solution, you have a mixture of ethanol and water. When you start evaporating your solvent here, obviously ethanol will go quicker than water. So locally here, you have an increase of your concentration of water. Also, locally, you have an increase of your concentration of surfactant. Those two things make the two processes that I've just described before happen at the same time. First, the increase of the concentration of surfactants will produce some micelles, and the more micelles you make, the more you will start organizing them. So it's as if you had your micelles in a solution and you started organizing them in the bottle of your Schlenk. You will organize them in arrays like that, over and over. This is exactly what happens here in the layer. At the same time, the concentration of water increases, which means that you have water that starts attacking your tetraethoxysilane to produce silica. So tetraethoxysilane is soluble, but silica is a solid. So you start polymerizing silica around your micelles. So I fill this out with silica all over. SiO2. This is silica. And inside the things here are my surfactants. In the end of the day, you can take this material in this form or in the form of the layer that I've just produced by my dipping, and you can wash off your surfactants or burn them by your thermolysis, and you will have an organized array of holes and walls of silica around it. I hope this video helped you understand this process. Bye bye.